Hey guys, this lesson we are going to be talking about the Java platform, and more specifically the Java Virtual Machine, or the JVM, and bytecodes. So first off, before we get into anything too deep, the first thing you need to understand is the Java programming language. Now this is just going to be an overall architecture. It's not going to include, how to program in Java. But the first thing you always have is the source code. Now this is going to be, you know, all your files that you write, the higher level architecture. And this includes, if you wanted to assign variables, your for loops, and, even a while loop. So source code, that gets compiled and it goes into a command that you do on the terminal or through, an IDE is different. But once you compile that, that goes into a .class file right here. And this .class file is what is known as bytecode. Now we'll get into that later. You don't need to worry about it right now. But where this bytecode comes in, it gets fed into this Java virtual machine right here. And this Java virtual machine, all its job is to produce machine code that then gets fed into the computer. If you're on a Mac or a Windows machine, this will be your computer right here. So why the JVM? Why is this part right here important? To get to that, we can go down to this little slide over here. So like I said before, this is going to be your source code. And in this example, it includes a class, and all we're doing is printing out something. Here is going to be your compiler. This is what we said was the javac command. That's not important right now. And then your bytecode are all these intermediate steps. And that gets imported into the JVM, and then here is your machine code. Your machine code gets produced by the JVM, and then these, I know they're different, but they should all be the same, and they get produced and inputted into these machines right here. Now, why bytecode? Let's get to that. So we have these bytecodes right here. What's the purpose of that? So for example, to illustrate this, let's say you have source code test.java. It gets inputted into a compiler, right, just as before on the left. And let's say you don't have the virtual machine. So you're going to go straight to, let's say you have a Mac. Let's pretend this is your Mac. And these are going to be the machine code that gets fed into your computer and gets run. Now, if you don't have bytecode, what if we have a different machine that's Windows? And the thing about this is that this same code right here, if it was over here on this side, the same stuff, this is not understood the same on Windows as it is on a Mac. Now, I know one option is you can have a different compiler or a different source code for each operating system. So this is going to, you can have different compilers that produce different source code for the same program specific to each environment. Now, that's not very efficient in some cases. Some programming languages do this, like C++ or C, but Java has a Java virtual machine that allows each machine to be specific to just its virtual environment, and it always produces machine code based on its environment that it's run on. So for example, if we look over here in this section on the left, this Windows machine, the JVM produces this different machine code because it's running on a Windows hardware platform. This JVM is producing different machine code for a Unix operating system that runs ultimately the same code, because this bytecode is the same. It's all produced from this program. So that's the main benefits of JVM is that you have this virtual machine that you only have to write your code once, and the compiler inputs it, produces the bytecode, which is your .class file, and the JVM takes care of all the other stuff, so it can be very platform independent. And to get into one more thing, the Java Application Programming Interface. Before we learn about the Java platform overview, this is just one thing we can talk about real quick. The Java API is basically just, I won't read this, you can read it, but it's just a set of classes and packages, which as Java calls it, that can be pre-used for stuff in your code that makes your life a lot easier, and you'll use this a lot in programming. And this can include stuff from list, maps, has your HTTP client, and any, JDBC connections, which is database connections. It can have your implementations of these, like array list, linked list, or even your hash map. And all of these are contained in predefined packages, or Java packages, that they provide for you. And all those packages are just called the Java Application Programming Interface. So finally, after all this, we get to the Java platform. So as before, we have the source code, right? This is your .java where you write your higher level code of, your for loops, your if statements, your assignment variables, any kind of code that you write. And then we have this hardware-based platform. Now this, if you look up here, is going to be these guys. So this is, I know it says hardware-based, but in the Java platform world, everything sits on top of a hardware-based platform, which is also software. So this is going to be software and hardware. This is stuff like, you know, Mac OS, Windows, Unix. This is the software platform on top of the hardware. So it's a combination of both. And finally, we get this is your bad boy, the Java platform. This includes the API. That is the stuff that you use to write your classes up here in the source file. And it also includes the JVM, or the Java Virtual Machine. And that is basically just how this right here gets translated and runs on these hardware-based platforms. Yeah, so that's basically it. The Java platform, you basically need to know that it's consisted of the Java Virtual Machine, which includes bytecode. That's the main thing about it, and platform independent. And also includes the Java Application Programming Interface. Yeah, that's about it, and thanks for watching.